Hello everyone. So in this session we'll be discussing about 0 or 1 knapsack problem using dynamic programming method. So now let us understand what do you mean by this 0 or 1 knapsack problem. So here 0 or 1 represent either we can add item to the knapsack or which will be represented by the integer 1 or we won't add any item at all. So here it represents that the main goal of this program is that in order to derive the maximum optimal solution by adding one or more items to the knapsack, and it should not exceed the total capacity of the given knapsack, right? So in order to do this we need three criteria, that is three important items or things. So we have n items, so which has a weight, so which will be represented by the variable w and the profit p, and number of items which will be represented by variable n, right? So as I said, we need to maximize total profit by selecting a subset of items. So, such that the total weight is less than or equal to m. So, m means capacity of the knapsack. Or, as I said, we can add a item completely, uh, or we won't add a item at all. Okay, so this is the basic idea behind the 0 or 1 knapsack. So as I said, there are three things which are associated with this knapsack, and with respect to this item, there is weight, profit, and the capacity. Okay, so here the user will enter the number of objects. So the number of object may be either two or three or four, or is it depends upon the user. So user will gonna enter the, so once the user is done with entering the number of objects they want, so next step is to enter the weights and profits for the number of objects which have been entered. So if the number of objects are three in numbers, so let's say for example n1, n2, and n3, so the user need to give weights for every object, right? So next they need to enter the profit for every objects which have been mentioned. So next is the most important step, that is to enter the capacity of the knapsack, right? So user need to enter the maximum capacity for the knapsack. So so when the user adds the item into the knapsack, it should not, that is the optimal solution should be maximum, and the weight of the added object should not exceed the capacity of the given knapsack, right? So next it will call the knapsack function. So it will call this knapsack function in order to perform the, so in order to solve from item 1 which with capacity of m, right? So this function, what it will do means, so this function uses recursion. So why it uses recursion is that, so should we include item I or to exclude item I, so it will call the knapsack function recursively in order to include or exclude the item I. Okay, so then what happens, so this is how the optimal solution of the knapsack is calculated, and finally it will print the maximum profit. So let us understand the 0 or 1 knapsack problem with the help of this sample output. So as you can see here, we are entering number of objects as 3, and weight for every object is given like this. So for the first object the weight is 10, and for the second object the weight is sorry, for the first object the weight is 100, for the second object, the weight is 10, and for the third object, the weight is 14. Okay, so they are followed by the profits. So the first item profit is 20, followed by the second item profit, which is 18. The third object profit is 15. Okay, so user need to enter the capacity of the knapsack as well. So now the question is, how do we obtain this? The optimal solution is 38. So just try to add all the weights of the objects and try to all the profits. So what happens is that it will exceed the capacity of the knapsack, right? So weight is exceeding the capacity. So weight itself is exceeding more than the capacity of the knapsack. So in the 116 kg of bag, if we try to add 250 kgs of weight, is it feasible? No, right? So can discard this. So now let us try to add the weight 110, right? So what's the total weight by adding two objects? It is 110. So what's the total profit we'll get by adding these two weight is that 20 plus 18, what is 38, right? So the optimal solution is the 38, right? So hope this is clear. Thank you.